what AWS has perfected, or anywhere I've worked in the past, which has, like Adobe, for example, which was a heavy AWS user, is fault tolerance and high availability aspect. What I mean by fault tolerance is, with the distributed system world where there are a lot of integration, failures are bound to happen. There's one component that's going to trigger a failure that's going to have a residual effect on others. But how quickly can you recover, right? Firstly, whenever there's a discussion between build versus buy, it's always try to build first, see what lessons you have learned, and if you think it's too much, then go and buy. Anybody who wants to grow their career significantly, because there's AI and there's ops, that is the key thing that they should target, because that's the biggest use case in ops that AI can solve for.
Okay.
AI ops is the next big thing in the SRE space.
Hello, and welcome to another edition of the Incidentally Reliable podcast, where we chat with veterans in reliability, talk about some dodge bullets, battle-tested engineering innovations, their war-zone stories, and their opinion on the current state of space. Today, we are joined by Amit, a seasoned leader with extensive experience in site reliability engineering. Amit's career path has taken him through various domains and companies, having worked at orgs like Adobe, Amazon, Loblaw before landing at his current stint as head of engineering at GoDaddy. Throughout his journey, he's tackled tight air budgets, ensured uptime for millions of users, and navigated the complexity of large-scale, high-available systems. Welcome, Amit. Really nice to have you today.
Thank you. I'm glad to be here.
Would love to know what's an average day for you looks like at GoDaddy, one of the most loved companies in the world, since everyone realized there's internet, right?
Yes. Good question. So, my day, like each day of the week is different, given that I'm meeting most of my cross-functional leaders in product, security, UX, and then some development teams as well. Given that site reliability engineering is a very distributed world, as you know, there are multiple facets to it. Apart from meeting these cross-functional leaders, I meet with the team to set the tone for the sprint, to direct the quarterly goals and the yearly plan that I have put together. So do a check-in with them, regular one-on-one with the managers and senior managers and principal engineers who are reporting to me. And then spend time looking at extensive like the data ingestion pipelines, the data workflows, and the scale at which we are operating, to make sure that we are creating highly available, fault-tolerant, reliable and scalable products for our customers. The four key businesses that we cater to in my role is, as you know, domains, hosting, commerce, and payments.
So, like everyone know that GoDaddy is one of the company where everyone trusts how their online presence is maintained, right? So, how does GoDaddy make sure about their reliability? What processes do you follow internally to make sure these reliability are intact?
Good question. So, there are many pillars to creating a site reliability engineering culture. Firstly, at each layer of the OSI stack, right from the physical, which is like our data center presence, with a lot of data centers that we own, operate, and maintain. Because we are a hosting provider, that's one of the key businesses. So security is a critical protocol, including securing the edge, network security, including application security. So that's one key thing that we always invest heavily, both in terms of the software that we build, the people that we hire, and the physical security that's required to maintain data center. Beyond that, as you mentioned, like for reliability, scaling up based on the increasing demands of the customers. We host like 61 million customers domains. And that too, they have run their entire website on our stack, which means we provide hosting, which requires storing their pictures, videos, which are, and many editing and custom content management solutions that they work with us. So that requires us to capacity plan for the future and increase our data center footprint, including our clouds and like cloud solutions and SaaS providers that we leverage to scale up. And so security is an important pillar, data center and data footprint is important, and so is building the applications to support.
What's the reliability stack look like, and how are your team distributed?
My team is distributed between like North America, like Seattle, Tempe, the Bay Area, on the East Coast. Some in London, UK, some in Eastern Europe. And then some in Asia Pacific, but none in India for my team. There are many other engineering teams based out of there. Our stack is basically variety. Given that we have been in business for more than 3.5 decades, or about 3 decades, we use Go, Java, Python. That's like our development languages. We have GitHub, GitLab in some areas. There is Datadog, LGTM styles, which is Loki, Grafana, Tempo, Mimir, which is the Grafana cloud that we have moved from ESSP or Elastic, given that they have changed the model of licensing recently, so we made that switch. But beyond that, there is a lot of ingestion that happens from Microsoft SCOM, Site 24/7. So these are stack I'm referring only in the observability and site reliability space. Beyond that, the data center for maintaining, we have a lot of hardware providers who like give us a substrate for the server. Our storage is built on Ceph, which is an open source data tool. So there's a heavy open source usage because our technical muscle and the engineering capability is high. That way we are building very robust, highly scalable, fault-tolerant products.
And a lot of the company talk about disaster recovery, right? Since you are a hosting partner for a lot of your customers, you are providing them hosting services to them. How do you make sure the DR for all those customers is managed? Do you have multiple data centers? Do you run multiple replicas?
Good question. So there is that function. I closely work with a data center engineering team, which is a separate function under the CTO that we both report into through our SVP. Now, disaster recovery has evolved at GoDaddy. Obviously, that plan has always been there in terms of what if there is a natural calamity that hits, what if there's a power outage, what if there is a fire, what if there is a security threat of some sort. So we have a like N+1. I can't reveal for NDA reasons of how much capability we have, given that it changes also in the region and to protect our customers' privacy. That way, we provide that, like, there are multiple regions within the US that we have data center presence, which is also public knowledge. There's many in Europe, like Germany, for example. That's our knowledge. There's Singapore and many other locations. Now, what we do is there is obviously a pilot kind of model that we run to augment the data flows between the data centers to protect the data first, right? And then obviously the hardware on which the applications are running. So they have multiple API endpoints to switch over. And we are one of the largest DNS providers. So we know like how to cut off those things when things go wrong in terms of a switch to another endpoint. So those capabilities are built in, but it has been a journey. A lot has been done prior to my leaders before me as well at the company, and I'm leveraging that space. But with the new advent of AI and machine data that gets generated heavily now, now we have to rethink our strategy around it. So I closely work with the data center engineering team, our networking team, and security team to get this all sorted, to at least their application, the infrastructure, and the reliability aspect is always maintained to utmost highest standard.
Yeah, I think name server is something which any domain listing company would actually start with, right?
Yes.
Yeah, they have to actually maintain distributed name server, maintaining equivalent records on different sides, right? So I think that is the base of GoDaddy.
Yes.
And this is, you actually do it by maintaining your own data center, or do you also rely on the cloud providers for the same?
Good question. We have our own significant large data center footprint to maintain that. Part of the reason why we do that is we are also one of the largest hosting providers, not in comparison to the cloud providers at their scale, but for our customers who want us to host their websites built on top of it and then leverage all their capabilities to scale their website, right? That's why, like, for us to have the utmost level of security to offer them as a product, and that was primarily the reason and the decision driver behind us maintaining and operating. So we have more significant data center presence than the cloud presence.
Okay. You were previously at Loblaw, right?
Yes.
And were responsible for establishing an SRE team for some major verticals like pharmacy and healthcare, media. and advertisement. What's the hardest thing about building an SRE function from ground up, and especially at a company with older engineering team, which have been running the engineering teams from decades, right? How do you evolve a new practice within that engineering culture?
Good question. So, Loblaw, just to give you some insights to the audience here, is a large retail company based out of Canada. Imagine it's like a Walmart plus CVS combined. So they have a physical store presence where you can buy A to Z things like you do at Walmart, and they have a pharmacy presence like you get at Walgreens or CVS, and an online presence as well. And you can dispense of online pharmacy prescription drugs in Canada, unlike the US. So traditionally,
in India, we have online.
yes, yes. So exactly. So here in Canada, challenge here there was a retail mindset right from the start.
Okay.
Vendors, contracting, siloed teams, and just delegating some stuff which are technical to folks outside the company. So the engineering muscle was not built strongly within. There was also a function called Loblaw Digital, which was separate, and Loblaw Technology was separate. So when I was brought in, part of the reason I was hired was to build an SRE practice from scratch for these groups.
Okay.
And to come back to your question, the challenge was to break down this mindsets of teams working in isolation where they have a clear delineation path of this is my responsibility, code to commit, nothing to do with where it runs, where it lands, how it scales up. Then when it comes to operations, so we get alerts, we notify the team, they take action, we don't do anything. So you see that there are already silos that exist, which means the fixing time or the MTTR is high.
Yeah.
Because the MTTD itself is high, and then there is a hot potato that gets thrown to other teams who owns the problem. So the first thing was to make sure that the culture and the mindset of SRE to build that gap was one major thing. I work with my leaders. Obviously, without their support and buy-in, this would have been impossible. So firstly, vision had to be built. They had to be bought into the vision. The advantages and values to their teams was to be proven, and then these practices had to be and policies were implemented, and the right set of engineers were hired, and the existing ones who didn't know this practice were trained on cloud certifications, sent to conferences, made sure that they have all the tools they need to succeed. So those were many things that I addressed to make sure that we are building that culture, we are creating that strength within the company of an SRE, and we are operating in as an SRE, not that just have the name or titles of SRE, but operating in our own way.
Did you limit the SRE practices within the cloud team, or was it adopted across different teams, and was it later on included as part of the logistics and delivery time as well?
Good question. So we started off with the cutting edge teams who were already cloud native, but they were like legacy team, I would call it, platform teams, so tech architecture and other teams who were usually very close to the data center side of the world. But there was a clear direction from our CTO, David Markwell, who had a plan of getting out of the data center, because that's not a business, right? We are not in the business of running data center. We are in a business of retail. So that's how we created a DC out strategy, means migrating to cloud. Because it's a 100-year-old company, but obviously the online presence has started only three decades for them. It took a lot of evaluation and due diligence to identify, Oracle is being used here, IBM is used, HP is used, Pivotal is used, OpenStack is used. But if you go to GCP, what does that equivalent is? Like, how long will it take for migrating the data, the apps, and then switch over? So that was the primary focus for us to move from the data center to that. But it started off with the cloud team who were proficient in it to build a baseline for us to move towards, and then these folks were brought in, and then the supply chain teams and other teams were brought in at the later stage, because they are very SAP driven, ERP, SAP, and at that time the logistics were at the tail end until the application was rehauled on cloud.
You also were involved in setting up DevSecOps function at Loblaw, right? But what kind of security threats did Loblaw face?
Security, as you know, security in any usually corporate provides policing, guardrails, and directions, right? But how to enforce them is to the interpretation of most of the engineering teams, and they can't dictate exactly how to do that, except that they have SOR tools, SOC tools, and others. So at Loblaw, that team had a big influence, as it should be in any company, because privacy, protection of your assets and customers' data is important. But what was an issue is anytime there was a security incident or issue that came in, be it DDoS or be it vulnerability that hits, be it patching that needs to be quickly hot patched, all hands were down and application rollout were slowed down. So like your production release stack is slowed down. So you see it's like everybody's running there. And over time, as we build a strong SOR practice, SOC practice, and then brought that security operation function closely in line with the DevOps function or SRE function, because that term is used interchangeably used. There's no DevOps function as such. SRE runs the DevSecOps function within Loblaw. So when they were brought in as key stakeholders, as key partners, that's when they could derive the value of how can we quickly identify the security issue here, what needs to be fixed, and how can we enable these development teams to do that fix faster. How can we proactively look out for vulnerabilities, patch systems, upgrade them without exposing network access lists, security groups, or any other threat models that we have. And then like not only protecting at the edge, but on the networking and at the app stack. So, but it's a journey. It took multiple iterations, multiple trial and errors, and some failures to reach there.
Okay, I think any cloud company out there, right? Especially AWS, everyone look up to them from the SRE perspective, the kind of uptime they have been able to maintain. Touch wood.
Yes.
So, what are some of the SRE or even general engineering practices which you have seen or which you have worked on within AWS, or which you think AWS has nailed into perfection?
So I used to work for, like, I had 2 stints at AWS. One was at S3, and the first stint was EC2.
I think S3 is a very good example.
So S3 is the largest, one of the largest distributed systems in the world. Eventual consistency, many nines of availability. I don't know, they have gone many nines after I, and there were 5 nines that were targeted. Now I think it's more than that. But what AWS has perfected, or anywhere I've worked in the past, which has, like Adobe, for example, which was a heavy AWS user, is like the fault tolerance and high availability aspect. What I mean by fault tolerance is with the distributed system world where there are a lot of integration, failures are bound to happen. There's one component that's going to trigger a failure that's going to have a residual effect on others. But how quickly can you recover? The idea is with AWS, the targeted MTTR set based on the SLIs and SLOs created right from the scratch. So at the start, when you write PR FAQs, at Amazon, we have a philosophy called PR FAQs, which is a TPM or a product manager write a press release document of what the product will, what questions that the product development will address when it goes to release, and how will it benefit customer right at the start, which means that we embed reliability, what MTTR, what SLIs they are targeting from
development itself,
in the development phase itself, so that the architecture as it evolves right from the first design to MVP to its scale, like with that S3 scale, which is used by Netflix and Apple and many others, is baked in. Now, is that true for other aspects of Amazon? No. But because the expectation of reliability for S3 is higher than some others, where if there's not issue of eventual consistency or other aspects, that was one of the biggest service at that time. EC2 and S3 was the biggest, right? And they were the first 2 that got released. One thing is, as I mentioned, high availability, fault tolerance means, and that too working at scale. So if components break, it has to recover fast. And it has to be disaster recovery is part of high availability, right? So there were multiple blob storage in S3 doesn't store at one location, as you know. Even Google Drive, it is not just to protect, because if you get hit by a natural calamity or something. But to put into your question, the reliability aspect is maintained with a very strict SLA that we have built, a very, very robust design, which is highly fault tolerant, which is globally distributed. There's multiple layers at which it's different. The objects are stored at very different layers, which is backed by volume storage as well to protect it from losing. And then the eventual consistency to make sure that once you access that updated object, you get the latest object in your response. So those are the key things for which MTTR was reduced by significantly. Hot partitioning problems were solved significantly over the course of time. And the latency, basically quick resolution, like if you're watching a video and all, Netflix and all is backed by S3. So if it's a device on a Mac or something on a Wi-Fi, how can that be adjusted? So those were the things that were added to improve the reliability of the service at that scale.
You also talked about EC2, right? So do you think they were doing anything separately or unique with EC2 apart from S3?
So if you look at EC2, there's an image AMI, which is actually stored in S3 on top.
Yeah.
That's how you spin up. But that's a compute instance. The expectation of running a compute instance on a substrate, which is like a data center rack or a specific server, and then the isolation for it. So the issues with EC2 is like, how can we reduce chatty neighbor issues? How can we reduce hot partitioning? How can we reduce, basically to make sure that security is prevailing at that layer. And then for EC2, it's a very different ballgame because it's a compute, which means it has to scale both horizontally and vertically. So there are M2s, IX, and different kind of. So that stack with S3, it's an object store. And then there is archival and glacier and many other things, right? Like Snowball, if you want to store it from data and whatnot. But the idea is the challenges are different, but there's certain overlaps where, as I mentioned, the SLIs, because we have a very strict SLA that we gave it to East customers. And there was a big outage, as you know, in 2017 where Adobe, Netflix, and a lot of customers, Instagram was down. At that time, the idea is we had to repay some of the customers because of the loss of business, because that's what the SLAs that we set. But does that mean that the team was fired for doing? No. It is a harder lesson. It is an important lesson, but that helped us to evolve S3 to the next level at that time, and then to a scale where it's at now. So anyway, so there are, and I think that is ingrained in Amazon's culture of not fearing for failure.
Okay. You led multiple teams in Adobe as well as later on also, where you worked on migrating from data centers to cloud like AWS or Azure. So when you're doing it, right, your SRE practices changes because you have to be more reliant on the cloud partners than you're doing it on. Your load decreases, but still your responsibility on the application side and deployment side increases, right? How did you think the new practices shaped there?
Sure. So I think it goes from an own, operate, maintain model to a shared own, operate, maintain model. So when you're doing it on your data center, everything from patching to the network to the power, everything you have to take care along with a DC engineering team if your company has one, and that we had one at Adobe as well. But when we shifted to multi-cloud in a hybrid model, AWS, Azure, and some India data centers for Adobe's 2 product lines for Marketing Cloud, and then there is another one, content management solution. So for those 2, the idea is when we started working with these cloud providers, firstly, we set up a margin of what the applications are currently doing, what are the latency requirements, what are the architectural guidelines, what tools and services that and their products are offering that they have, should we leverage, and then did a data plus app migration on top of it. Now, as far as practices have changed, it reduced the overhead for us to maintain entire layers of the stack, right? Networking, power, and others. So that aspect we completely offloaded, and we completely switched to focusing on the application and the infrastructure scale up of it. Now, the other aspect of managing the assets itself and the security has reduced because AWS has advanced mechanisms to protect its regions and the data centers, right? So that means we started focusing on the business side more. for product feature releases more than maintaining. So that actually, to be honest, it saved a lot of cycles for us on the tech debt, on the old things of maintaining more, not adding much good value, just keeping old systems in healthy KTLO state. So it basically, we completely paradigm the shift was there in the team to go closer to the development cycle, to release more features faster, to scale faster, because we are not maintaining old systems.
But it was a bit of a personal question, I think, because we know now a bit of idea of what have you been contributing in various companies you have worked on, right?
Mm-hmm.
How did you evolve from a previous role to an SRE? What has been that evolve or change for you like? Or how did you pick up SRE or did SRE pick you?
Good question. So if you quickly, I'll give you a quick background. I started working for Tata Communications, which is a conglomerate based in Mumbai, which serves undersea optical fiber cable management, which terminates in India. All the India's internet backbone is feeding through Tata. At that time, I was a part of a network operations center. That was my first job. Then I moved to satellite operations, which is basically uplinking TV channels and signals
Within Tata itself?
within Tata, which was correlated with Tata Sky.
Okay.
And fortunately, in 2011, I was in Delhi in the studio to get feed from the World Cup locations and could
nice.
distribute. So I was a very
So
big
you were not contributing that latency which we were seeing.
Sometimes there was an issue because, but we partnered with Globecast and ESPN, who had global rights to sell, showcase that content. But Tata was the technical partner for them. Now, the reason why, if you look at my background, I started in telecom backend engineering. I did code in Python, Ruby, and all that Perl methods which are required in that. And I've always been in the infrastructure, physical server, telecom, SDH equipment, WDM equipment, which is like wavelength division multiplexing, synchronous digital hierarchy. These are like telecom.
Yeah.
And then I came to the US for my master's in computer engineering plus telecom combination. And plus there's some business side of it. So you can do multiple aspects. That when I got exposed to that, I interned at Akamai, which is a DNS and cloud front, which is like similarly they have a CDN, one of the largest CDN providers. Apple uses them extensively. And then I started my first role after graduation in the US with AWS and EC2. So I think infrastructure has been in my career. So I think SRE chose me. And then over time, as I got access to variety of distributed systems, architectures and all, I felt that there was no structure, like there was developers, there's product management, but what is the glue that ties? But that's when the Google coined the word SRE in 15-16. And then that function grew to in the last 9-10 years so significantly. And I think that's how I remained in that. And then I grew into the leadership roles to drive big missions in that area.
How was the evolution? Well, since we talked about data communication and data sky, right? How was the evolution do you see from someone from the telecom domain and then shifting completely to the software, highly scalable system, right? Because I think telecom is the first sector where the scale was already there.
Yes.
You were already handling millions or billions of requests at that particular time. The internet came afterwards when everything moved to internet and not interconnected, right? How do you see the experience being different?
Good question, actually, and good that you completely could relate to my story. And because of the scale,
I was part of Sasuke and I was working as a telecom engineer for a few months there. My interest was there.
Sure. So, I mean, telecom back then in India in 2008 and 9 was booming now as well it would be. But the idea is scale was there, but like we are like, you look at it as we are looking at a pipe.
So,
In pipe, there are data packets flowing. But what does that each data that packet that flows, particularly in an OFC, which is an optical fiber cable, is coming from different application, but the intelligence is the application. This is just a conduit or a physical structure. And as you look at the OSI model, the intelligence is at the top layer, not at the physical layer. That's where I wanted to move, but I didn't have the right skills because I was I am an electronics and telecom engineer. We had coding in our curriculum. I did coding for my job as well, but it was not as heavy as a developer. But when I came for masters, that's when I had a moment of reset. That this is the time I have to switch.
Okay.
And that's when I switched from CD and I interned at Akamai for 9 months. And then with Amazon, I got the opportunity. And then since then, I've never looked back.
Okay, nice. Have you, how do you envision AI ops leverage at GoDaddy or to optimize operation? Or are you even exploring AI ops at the
Yes, absolutely. We have been on this journey for the last 2.5 years now. AI ops to us is basically what search is for like for Google, right? So what I mean by that is, I run the SRE practice for these 4 line of businesses, and a lot of my team's time is spent on incident management, on ITSM things, and what we want to do is add a value. So to reduce that, what we are using AI to feed in data, correlate from various different sources, which means there might be a breakdown in any place. We can correlate, normalize, enrich that, and identify using AI, which means the human intervention of correlating, oh, there is an issue here, though this might be the branch or something. That's done automatically with the AI engine, which we use Big Panda, which is a company that we leverage. There's some Apache and i5 based open source story that we have built, which is a data orchestration pipeline, which is like open source, and we build an event ingestion platform internally at GoDaddy. So in combination with that, that helped us reduce like the development teams, the product teams cycle times in identifying, because then they can just on one pane of glass can see where things are, which can be rolled back, and then that reduce our MTTR significantly, because AI helped us reduce that correlation and the time to like look out where the issue is. And I think just the second part of the question is the how do I see the evolution? I think in SRE or infrastructure, anybody who wants to like grow their career significantly, because there's AI and there's ops, that is the key thing that they should target, because that's the biggest use case in ops that AI can solve for.
Okay.
Now, the reason why I say that is a lot of companies have started investing in it, because there are tools which are in the outbound side through ServiceNow, which does incident management and alerting, PagerDuty and all. A lot of those can be automated with a chatbot and other aspects. So if you know how this intelligence engine works at start, those other workflows can be built on top of it. This has to be perfected first, this first problem set, to build the other functionality. So if for your audience, if somebody is new in the industry and want to go or get a career advice, I would say look out and don't worry about whether you're late or not. It's not too late to start with AI ops. AI ops is the next big thing in the SRE space.
What kind of problems in monitoring or incident response do companies like GoDaddy, Adobe, or AWS face?
Yeah, so in monitoring, there is like, as you know, like there's metrics collection, there is scraping of data, and then through that you create dashboard alerts, thresholds to trigger an event, maybe an incident or a major outage, right? And based on the needs of an application, the component and the criticality, there's a tiering that is done in companies like this, tier 1, tier 0, tier 3 services, which dictate on what aspects should we alert of. What are the thresholds? What are the strict SREs? Like tier 1, so like tier 0, tier like EC2, S3, these are like tier 0 services. Like you cannot get it down. If it goes down, you're bleeding like money, right? So in Adobe, there were some things which were tier 1, some things which were tier 2, which are mission critical. And at Adobe as well, there's a tier. I think these CTOs have perfected that strategy over time of where that fits in. So anywhere I've built, these things were already put in place now. But as far as observability is concerned, that's a newer term or newer kid in the block. Monitoring we have done, but what does it mean from a full stack view, 360 view? A lot of teams don't get that. That's why DevOps became DevSecOps. Now I think it's going to be like, there will be all this integration that comes in will help us provide insights to a UX team, a product team, a development team, an ops team. And that's what observability is like is the next thing in the monitoring space, and we have taken on that journey, but it's still work in progress for us.
Does GoDaddy actively contribute to open source or leverage open source project?
Absolutely. We are like one of the biggest users of Apache Foundation's products, CNCS products, actually, because in the company, there's firstly, whenever there's a discussion between build versus buy, it's always try to build first, see what lessons you have learned, and if you think it's too much, then go and buy, which is like a SaaS product, like from a SaaS product, right? So that has been a company's mission from the start. So we use Apache's, Li-Fi, Kafka, many things which are built on open source. That's part of the reason why we are also so robust and heavily have a heavy engineering muscle within the company. Now, to put it simply, I don't think we have released product like, for example, Uber released Yager, Netflix released some other things, right? That those kind of things didn't come out because what we have, I don't know, for good or bad reasons, we limited to our problem space. We didn't go and explore the entire user space there of what problems can it solve, because we are a relatively smaller company in comparison, but we're heavy users of open source and have been heavy contributors to this mission.
Okay. So before we end this, we always ask our speakers about the boardroom stories, if they can share without actually violating any NDA, right? Do you have any boardroom stories which may be of interest to our viewers?
Sure, I can give you a big example of Amazon's aspect, because both the scale of it, the impact of it, the visibility of it was higher too. So I won't name the Canadian banking customer. There was a banking customer who was getting onboarded. Like they were trying to do a performance test between AWS and Azure for their S3 Lambda EC2 workspace, because they have a huge data center presence. So they wanted to stress test what these capabilities can offer, and they had a cutting edge data center presence. As you know, banking is governed by very strict laws, so they use stricter security policies. When they were running, there were Lambda concurrency issues that started to happen, which had started to cascade into S3 and later EC2 by creating a hot partitioning and a chatty neighbor problem on the running. Because of the workloads, there were microservices, multiple things are running. Then these were like performance tests that they were running. And this was a win or lose situation for the account rep who would onboard them with us, or we lose that business to Azure. So while that performance test, like our team was on high alert to make sure that this goes successfully, the things are set up in a way to make sure. And to be honest, there was also a challenge of procuring server, and really like Canada had a relatively newer region, so it was not as scaled as what we have in Virginia and elsewhere. So we had to plan the capacity for the same to get everything set up to make sure that they are. And it's surprising, as you may hear, that maybe AWS is thinking about capacity, but this was like, if you're talking about new region and one of the biggest customer in Canada, trust me, it can quickly scale up. But the war room was like, then the concurrency issue started to surface. So we had to like bring in the Lambda leaders, the EC2 and S3 leaders, and identify how can we actually offload some of that to like throttle some of the calls to other entities which have been calling there for other tests, to make room for this this new workload for their time. Very unique in how we operate, but we made that exception just because to want to make sure that the customer is happy with the results. We deliver the value that they have. Not unsurprising of Amazon, but surprising enough that they did that at that scale for a Canadian banking customer. Ultimately, then they were onboarded on us after a few months of negotiation. But in the war room, there was a lot of pressure to get things right. There were new dashboards created, retesting of those, making like new servers that before they get rolled out and available for running those tests, they were thoroughly tested. Health checks were created separately, advanced ones. Then queries were run to see if it's actually making sense. So that's one more story that I can share without dwelling too much on the names of it. But very big learning for me on how the solutions architect, the account teams, the VPs and the engineers all came together to help solve that. One of the key moments and big learning for me here.
Thank you. I think with the kind of experience and kind of stories which you have, this could go on and on. But we'll actually close it for today. I thank Amit for actually joining me today for this quick podcast. And thank you very much.
Thank you all.